Okay guys, so we're going to look at the squeeze theorem for this problem. So we're looking at the limit as x is approaching 0 of x squared of cosine 7 over x. So when we're trying to find this limit, obviously we can't plug in 0 into here. We could plug in a 0 into this x squared and get 0, but you can't plug 0 into the denominator of this problem because it'll be undefined. The best way to probably go about this function is the squeeze theorem. The reason that I know that the squeeze theorem is probably going to be the best solution for this problem is because you're going to see the squeeze theorem a lot. Not a lot, but you're going to see the squeeze theorem with kind of this format of problems. Like if you see some kind of function, like whether it's like e to the x or like x squared or just x or like something like that times a trig function like cosine or sine of x. And the reason that we're going to see that is because it's really easy to put a problem like this using one of these trig functions times another function into the squeeze theorem, because when we're looking at the cosine or the sine function, we are looking at a graph that oscillates between 1 and -1. So cosine, this is not a great graph, but like you guys know, whatever. It's between 1 and -1. So we are able to write that -1 is less than or equal to cosine x, which is less than or equal to 1. But in this case, we don't have x, we have 7 over x. So having it in this format makes it kind of easy to put it into the squeeze theorem format, which is where we have, if we have f of x is less than or equal to h of x, which is less than or equal to g of x, then we know that if the limit as x approaches a of f of x equals L, and the limit as x approaches a of g of x also equals L. So this L is representing a y value. So when we're saying L, say like the number is 7. So if your limit of your f of x function, so whatever the function is that would be over in this spot is, this is not a function, this is the number -1, but we are going to get a function into this spot. If that function were to equal 7, and then once we get a function into here, if that function were also to equal 7, then our function in the middle, this h of x, limit as h of x, as x is approaching a, whatever that a value is, that would also equal 7, or L. Or if these two both equal the same L value, then this is also going to equal the same L value. So that's kind of the whole idea behind the squeeze theorem, and the reason that we're working with this cosine 7x, because we know that if we have a cosine function, no matter what, it's going to be between -1 and 1. And so in order to turn this cosine 7x into this function right here, because our h of x is equal to x squared times cosine 7x, all we have to do is multiply each part of this equation by x squared. And so if we multiply each part of this equation by x squared, we're going to have negative x squared is less than or equal to x squared times cosine 7 over x, which is the function that we want to work with. So that's perfect. We have that as our h of x in the middle, which is less than or equal to x squared. And so now that we have our functions written like this, what we can see is we can call this function our f of x, this is our h of x, and then this is our g of x. And now that these functions are in this format, all we have to do is test out our squeeze theorem to see if the limit as we're approaching 0 of our f of x equals the limit as we're approaching 0 of our g of x. And then if those two are the same value, then that is what our h of x function is going to be, and that is what we're trying to find with the squeeze theorem problem. So what we're going to do is we're going to plug in 0 into this equation. So we're going to plug in our limit as x is approaching 0 of our f of x, which is equal to the limit as x is approaching 0, and we said that our f of x function is equal to negative x squared, so of negative x squared. And then, as you guys know, for limits, you just plug your a value into your x value. So we have the limit as x is approaching 0 of 0 squared, which is obviously equal to 0. So now we're going to test out our g of x, which is the limit as x is approaching 0 of g of x, which is equal to the limit as x is approaching 0 of x squared. And then plugging that 0 in for that a value, we have the limit as x is approaching 0 of 0 squared, which is obviously equal to 0. Also, I see up here I missed that negative sign, so that was supposed to be negative 0 squared, which is, again, that's just 0 squared. And so now this 0 is representing our L, so our L is equal to 0. And so what we see is that our limit of our f of x as x is approaching 0 is equal to 0, which is also the same limit we found of our g of x as x is approaching 0. And so now, by the squeeze theorem, we can say that the limit as of our h of x as x is approaching 0 is going to be equal to 0, and our limit of our h of x function, we said our h of x function is this x squared times cosine over 7x. So we have the limit as x is approaching 0 of x squared times cosine 7 over x is going to be equal to 0 by the squeeze theorem.